Great, the program is going well. I hope you're enjoying this. It's not a big program, so we don't have lots of code here, but however, this implements quite a lot of aspects of Python. So we're loading data in Python into a Python data type, and we have functions, we have conditionals here, we have user input, and later on we're also going to implement for loops in this code. So we'll talk about that later, why we need for loops. And so we have libraries, we're importing libraries here. And so this is JSON. We also need to import the difflib library, which we are currently working on. So let's focus on difflib for now. And what we have is, we pass this rain string with double N here. And we got a set of suggestions. So the best matches of the word rain out of the keys of our dictionary. But the user may also pass a word that doesn't exist at all and it doesn't have any similar matches there like that. So basically you have three scenarios. The user enters the exact word like rain and immediately you return data so with that particular key. That's the first scenario. The second scenario is when the user enters a word that is very close to one of the words you have in your dictionary, so like rain with an extra N. In that case, you want to return the first item of the list that the getCloseMatches generates. And the third scenario is when you get an empty list, which means that there is no such word or similar to that in your list. And so we have three scenarios, which means we need to sort of apply three conditionals in the conditional block here. At the moment we have only two, so we need one more which says, did you mean this word? So please double check it. For now we we'll just pass a message and also note something. You may also want to pass a higher cutoff value there, like 0.8, because sometimes if this is a low, like 0.5, and you pass like some random word, that will suggest you a few words which maybe you don't want. So you may want to play around with that. In that case you get an empty list. I think I'll use a 0.8 value for the cutoff when I implement it in the script here. So let's go to our code. The first thing we need to check is if the word is in data and return the value for that word. You may ask, what if you want to check for similarities first and not this? Well, I think the first conditional you need to apply is the one that you think will have more occurrences. So if you think that most of the users will enter the correct word, then you need to check for that conditional first. You don't want the program to go through the conditionals that have less probability to happen. So you first want to go through this, and then the others are ignored if this returns to true. If this doesn't return to true, if it's false, then you want to check for another conditional. And when you check for more than two conditionals, you need to implement the elif statement. So for multiple conditionals. And so we need to we need to check whether this list is empty or not. So if it's not empty, that means we got a match in the dictionary. In that case, we want to suggest that match. We want to mention that match in the message. So which means that if let me import it first. From difflib import get close matches. So if elif get close matches with the word given in data.keys, like that. So this is a list object, right? That's the same thing as this one here. So this is a list object, and you want to check whether the length of that list is greater than 0. If it is, you want to return a message. Let's say, did you mean? We use a string formatter here, %s. I'll explain what that is. Instead, did you mean that instead? And after the string, after you have closed quotes, you use the % operator, and here you pass a variable that will replace this formatter inside this string. So this will be replaced with whatever variable you pass all the right to this here. In our case, we want to pass get close matches for w and ... keys, and you want to get the first element of that list and put it here. So this is to understand it. Let's say we have a variable which has a value of 1, and you say, hey, as like that, %a, and the %s will be replaced with 1. That's the same what we're doing in here. And yeah, that's all we have to do else. So if this evaluates to false, and this evaluates to false as well, then what that means is we're dealing with an empty list. So the user entered a word that didn't have any match in our dictionary and didn't have any similar word in our dictionary. So you want to return the word doesn't exist. Let me save the script. Go to the terminal, the upper arrow key to call a previously executed command. So Python 3 app1.py execute enter word. Let me start with a correct word, rain, and you get the definitions for rain. Let me execute again, rain with an extra n, and yeah, we get this message, did you mean rain instead? So the %s was replaced with the first item of the list returned by get close matches. And again, if pass a very random string there, it says the word doesn't exist, please double check it. And yeah, that's it. However, I still see an issue with this, so we still can make the program more user-friendly. The problem now is that when the user enters like rain by mistake, what you say, you just pass a message there saying that, oh, did you mean rain instead? Oh, yes, I mean rain, but how can I enter rain? Why do I have to execute the program again? So I'm thinking of a solution where instead of just passing a message here and ending the program, instead of that, you execute another input statement. So another input statement, another input function like that, this one in here, where you ask the user to enter, let's say, y if they meant rain, or n for no, so y for yes, n for no, if they didn't mean rain. So if yes, then you basically pass, you return the value for the rain word. If they pass no to the input message, then you say sorry if that's not the word that you meant, then we don't know what you have in mind. So we say the word doesn't exist, please double check it. That's what I'm thinking. And yeah, think about this, and I'm going to implement it in the next lecture. Talk to you there.